Okay, so you have example number 2. Find two positive integers having a sum of 132 and the sum of their cubes as the minimum value. So we identify, it says the sum of their cubes has the minimum value. This is what we are trying to minimize. So we just write down the two equations that was mentioned. Two positive integers having the sum of 132. So we'll have basically we have x and y. So x is the first positive integer, and you have y as the second positive integer, and then we have s as let's have s as the sum of their cubes. This will be minimized later on. Okay, so you have x plus y is equal to 132 as our first equation, then the sum of their cubes. So the other one would be x cubed plus y cubed is equal to s, which will be minimized later on. Okay, so the thing here is what we would like to do is to derive something with respect to just one variable, because if we derive this s here, you'll have x and y. So we will use the first equation to rewrite the second equation in just a single variable. So how are we going to do that? Rewrite one, and then this will become y is equal to, we just transpose x, 132 minus x. Then we substitute 1 into 2. So that will give us y. Now will have a value of 132 minus x. So we have x cubed plus 132 minus x. We substitute it to y. Then you have s, and then derive s. Okay, so how are we going to derive s? The derivative of s with respect to x. So we'll have x cubed, 3x squared is derived. And then the next term we'll just use chain rule. So 3, then 132 minus x raised to 3 minus 1. And then the derivative of what's inside is negative 1. Alright, rewriting, let's use this side here. We'll have ds over dx equal to 3x squared. And then we have plus or minus, because you have a negative sign there. Let's just apply negative 3, then 132 minus x squared. Expanding, so we can have a better view of the equation. 3x squared minus 3, then 132 squared is 17,424. Then you multiply 132 times negative x times 2, so you have negative 264x, and then you have x squared. Okay, and then we can factor out 3, and you have x squared minus, let's have x, we'll distribute the negative sign, x squared, and then plus 264x minus 17,424. Okay, remember we place to get the minimum of s, we equate it to 0 to get the minimum. Okay, so with that we substitute 0, put it here. 0 is equal to 3 times, we just cancel x squared, 264x minus 17424. We divide both sides by 3, so we'll just get rid of 3 here. You get 0 is equal to 264x minus 17,424, We get the value of x as 17,424 is equal to 64x. Divide both sides by 264. 264. You got your x value as 66. Okay? So using this, remember, we know our first equation is y is equal to, okay, therefore, y is equal to 132 minus x. So we get y is equal to 132 minus 66, which is also 66. So basically, we have x as 66 and then y as 66. To verify this critical value as the minimum, no? So you'll get the second derivative. So let's just use a second derivative test so we can just substitute the values. Remember, we have the first derivative as 3x squared. Let's have the second derivative of x. So that will be 6x. By the way, we're looking at this first derivative equation. And then and then we have 3 as a constant, so we just put 3 here and then derive what is inside. Negative pala because of the negative sign there, negative 1. Just put it here, then we just derive this part of the equation. So it will be 2 times 132 minus x, tapos 2 squared na siya, minus 1, and then the derivative of what's inside is negative 1. So substitute, rewriting the values, you'll get plus 6 and 132 minus x. We can have 6x plus or minus 6x plus we have 6 times 132. That's 792. This will cancel out. Your second derivative will have a value of 792. So when you put in your critical value 66, you'll end up with the same answer. So since it's greater than 0, then it's a minimum. That verifies our answers.